First, as those of you who actually saw my emails, there was a big security problem with the Sequoia server on which the CS428 website resides. And they were afraid they were going to take the whole thing down without being able to move the data elsewhere. So I was a little panicked in the second half of the week. I started doing screenshot saves as PDF so I could recreate it on WordPress or something. And fortunately, they did find they were able to track down a former grad student who had the root password. Actually, he didn't have the original root password, but he had an account on the server which had super user privileges. So he logged in and changed the root password and then passed that on to the person running the server here at CS department. Anyway, so all is fine. I think a few of you had trouble getting to the podcast last week.
What was the issue?
Huh?
What was the issue?
It was a compromised FTP port.
Okay, I think I know what some of those words mean.
And basically, it was allowing access through this particular port via FTP was allowing people root access to the server.
So why can't they just get root access that way?
Huh?
Was it like an exploited FTP server, like an outdated version that had a known exploit?
I don't know. I don't know. Someone in the management just said we have a serious security hole here on the server. We've got to plug it, but we can't plug it unless we get the root password.
Just in case, should we all wget the entire website right now?
No, it's not yours. It's the website itself is fine at this point.
Okay.
This was a potential, not that there was a known attack going on, but doing a scan, they said, oh my gosh, this is an old operating system, it's an old FTP portion here, we need to fix this. We may have to take the server down if we can't fix it ourselves.
Okay.
But they can fix it, and we'll probably migrate everything and upgrade everything over the summer when I'm not teaching. We're going to talk about the next assignment now. Depending on timing, I'd like to give you a bathroom break, not at Worley still, but not at the change of class. Now that you have your requirements, now that you have an initial thought of what your requirements are going to be, better said, your next assignment is to create a Pert and a Gantt chart for your team. You're going to create both a Pert chart and a Gantt chart. We're going to talk about these right now. Well, let's talk about them. Challenges of devising a schedule. This will be a constant theme through this class, by the way, because there are few things more difficult than estimating software tasks. Because of ARMOR, because of the discovery. I mean, the folks doing Ethereum are pretty much saying we're all in research. We don't know what we're doing. The rest of you, to the extent that you're doing something you haven't done before, you've got a discovery issue. To the extent that you're using outside technology that you haven't used in exactly this way before, you're doing discovery. So the more novel you work, the longer it's going to take. And as programmers, of course, we think everything's a simple matter of programming, SMOP. Oh yeah, I can code that up in the afternoon.
That's not a simple.
So the first challenge, now that you have a requirements document, what you need to do as teams is to think through all the tasks that need to be done in order to build your minimum viable product. You need to think about the hardest tasks. Remember the article in the readings, which I think was already in one of the reading sets. Do not defer the difficult. It's easy to say, oh yeah, we'll deal with that server stuff like in start of April. You get to start of April, it's like, oh my gosh, we have no idea how to do this. You want to be able to identify the critical path so you know, and that's what the Pert chart is for. You know that if a particular task slips, the whole project deadline slips. That's what a critical path is. It's the path of greatest estimated duration of work among all the tasks. And you need to keep the schedule up to date. In other words, much like your requirements document, the Pert Gantt charts shouldn't be done once and ignored. trust me, I see a lot of failed projects where that's exactly what happens. They create a PERT or a Gantt chart, and they never update it again. And basically, it bears less and less resemblance to reality as time goes on. Another problem with PERT, just saying, another problem with PERT and Gantt charts is that they tend to be by nature waterfallish, and if you're doing an agile or highly iterative process, it may take some creativity to craft it in such a way that it reflects what you're trying to do. Yes?
It's like all of it, like all of like the task management, like tasking out a job, sounds like something you could like. It sounds like something would benefit greatly from like having a program to do that. Can you like recommend any good like software?
There are actually lots and lots of project management tools out there. There's some that have been around literally for decades, like MS Project, Microsoft Project. There are open source and free either downloadable tools or free online tools. If you simply Google, free PERT tool or free Gantt chart tool, you will find hits.
Okay.
So do that. For your Gantt chart, there is a free template if you've got Microsoft Excel called Project Planner, which basically allows you to create a Gantt chart within a spreadsheet. And we'll talk about that in a second here.
So like any you would recommend or recommend that we absolutely do not touch?
No, Microsoft Project is expensive. You have to buy a license, so on and so forth. I would look around for
We get
something.
that license for free.
Huh?
MS Project's over $1,000.
There you go.
Well, I think we get it like probably for free, like through the.
Do you have an academic license?
Yeah, I think we can like use it for free.
I think the issue I might have with you using MS Project, feel free to, if you can get a free license, academic license, by all means do it. But I suspect the learning curve is relatively steep.
Okay.
So you may have to sign someone on the team saying, you're learning MS Project. And you have to have this chart done in the next week.
So,
It may be easier finding some of the simpler stuff online. Pert Chart was developed by the U.S. Navy in the 1950s for building the Polaris nuclear submarine. It looks like, so you know what I'm talking about, that's a very simple Pert chart. It's a slightly more complex Pert chart. So let's go back. You have nodes, a box or a bubble. There's actually two approaches to Pert charts. One is the node is the task with the duration involved. The other is that the node represents the end of a task, and it's the arrow pointing into the node that's the actual task with the duration involved. I'll show you examples of both here. But the basic idea, let's just take the bubble box, whatever you're doing, is the task. Here's the task. Have arrows coming in from all tasks that have to be completed before I can start this. When this task is completed, I then have arrows going out, if any, and then I should say if any for either one. If there are other tasks that cannot be started until this one is completed, then I have an arrow pointing to those. You start at start, you end with your MVP or whatever, and you do this to identify the dependencies among your tasks and to identify, speak normally here, the critical path, which is the longest path of duration from start to finish. The reason that's important is because if any task on the critical path slips or is late, the whole project's late. Whereas if you have tasks that are not on a critical path and they slip for whatever reason, it doesn't affect the ultimate deadline. So here's an extremely simple PERT chart. Got 4 tasks here with the durations listed. You got start and end. So you've got, at the start, you can immediately start task 1, task 2, and task 4. They all have different durations. Task 3 depends on both task 1 and task 2. Task 3 here, come on, there you go. That's a pretty wussy green dot. And it depends on both these being done. It has a task of 9 days. So, quick inspection, where's the critical path?
1, 3.
1, 3. 12 days. It takes you 12 days to get from start to end through 1 and 3. It's 11 days here and it's 10 days here. So task 4 can actually slip by 2 days and it won't affect the deadline, because it's going to take you 12 days to get through 1 and 3. So if task 4 takes 12 days, it doesn't matter. If task 4 takes 13 days, it's just become the new critical path. And that's why you track this and keep it up to date, so that at any given time you can see where the critical path is. Here is this is a variant style. This is where the tasks are the arrows, and you've got the task and its duration. So going here, the critical path has been identified as B, E, H, J. Got 2 days, 3 days, 5 days, 6 days. This is dying. Anyway. So if you go through here, they've outlined the critical path in green. That's the longest path. But again, if something starts to take longer, you can have either parallel critical paths that are taking the same amount of time, or a new critical path in the project. So the challenge you face is that you need to take your requirements, and from that, build a list of the major tasks and or key events that are going to be required completion, what the dependencies are among them. In other words, before I can do X, I have to do A and B. There are cases, as I note, where I can start a task, I can start X before B is completed, but I cannot complete X until B is completed. And I'll let you play around and figure out. If you have that, you can figure out what's needed. What other tasks cannot be started until it's completed? So X, what other tasks in my project can I not start until X is done? Or done sufficiently. And if you're going to do iterative stuff, what you can do is do X, X prime, X double prime, and so on, and represent in each case a round through there. Yes?
So should those intermediate steps be represented distinctly, or kind of explained as its own thing?
Whatever, the point of the chart is that the chart, and this actually gets to the heart of the problem with IT project documentation. If it's not useful, it doesn't get updated, and it doesn't get used. So, when you look at what you're doing, your methodology, your approach, your technology, keep carefully in mind, how does this help the whole team to understand the project? In other words, does this chart actually, I mean, it's an assignment you have to turn in, but the real question is this something that helps us as a team to understand where the project is at any given time and what needs to be done? And incidentally, how to divide up work. This also means you need to agree to some extent on first order estimates as to how long each of these tasks are going to take. Now this is such a classic. You all have done this mentally in your classes and so on. It's like, okay, I've got to do these 3 things. This one's going to take me a week. This will take me 2 weeks. This will take me a week. It's going to be 4 weeks. The problem is we more often than not are sort of pulling those numbers out of thin air. And they often bear little resemblance to reality. And we find A actually takes us 3 weeks, and then we start to panic.
I can assure you the panic begins well before then.
Yeah. Here is my pro tip here. First, identify the hardest tasks and estimate those first. And second, start from the end and work backwards. There's this phenomenon which I can't tell you how many times I've seen it. It's to use an old Sidney Harris cartoon. It's like, okay, here we have this stuff that we're going to do, and then we're going to do this stuff, and we're also going to do this stuff in parallel, and then these two are going to feed into this one in parallel, and then, as per the old Sidney, a miracle occurs. and we ship. There's often this mental bit bucket that we put at the end of a project. Oh yeah, we'll do that when we get to the end.
Right.
And we often don't realize how many bits we've dropped into that bucket until we get to the end and suddenly realize, you know, you've got another 3 months worth of work in this bit bucket. So if you start from, this is what shipping or, you know, making our MVP available looks like. And just before that happens, here's what we need to have done. In order to actually release our MVP, we need to have this done, we need to have this done, we need to have this done. And then, in order for this to be done, we have to have this done, and we have to have this done, and that's needed for that, and that's got its own thing here, and this has got this. And then for these two to be done, frankly, working backwards like this, it's scary because you realize that you probably really don't have enough time to do what you want to do. But it's also a more effective way to get realistic estimates, and that's the point at which you say, okay, let's go back to our MVP and let's cut it in half. Because to ship this MVP, to have this available on April 9th, this has to be done April 2nd, and in order for that to be done, this has to be done March 25th or whatever the right date would be, not 25th, anyway. But so on and working backwards, yeah.
So, would you use like a Pert chart exclusively for development tasks, or could you also include stuff like marketing in there, all pointing towards like release date?
If it affects the release date, no, you can put anything you want in there.
Okay.
Pert chart says, I mean, if you have an MVP, but you have, you know, this is a commercial product, you're doing a 1.0 release, and you have no PR, you have no marketing, you have no product packaging, you haven't made arrangements with, what's the Google store? Google Buy? Google Play. I made arrangements with Google Play or the App Store to do stuff, and all of a sudden you're there with a product and you haven't done everything else that you need to do or to get out of the market. So what you're going to do is the two things you're going to do is you're going to do a Pert chart and you're going to do a Gantt chart. We're going to talk about Gantt charts in just a second. Google Pert chart tool. You'll find free charts out there. You can use any sort of, I mean, quite frankly, you can do a Pert chart with Microsoft Word just using boxes and arrows and so on. But there are better free tools out there. And you want to, this is something you're agreeing on. I mean, this is, here are your internal negotiations on the team. You've got to decide, what are the tasks? You really need to decide who's going to be doing the tasks, at least in general principle, because work doesn't get done by itself. Well, a lot of corporations tend to think it is. Oh yeah, someone's going to do that. Well, who's going to do it, and what else do they have as requirements, or as dependencies? Gantt Charts was actually created by a man named Henry Gantt. It's not an acronym, unlike Pert. I'm sure you've all seen Gantt Charts. This is, let me skip ahead. This is the most common Gantt chart layout you see. I think this is Microsoft Project. I could be wrong. Here's a simpler form, which is perfectly fine. But the whole point of a Gantt chart is that it's a 2D layout. You have your tasks at some level of detail on the vertical axis, and going across is simply a calendar. And you're showing when tasks are going to start and stop. And you often show dependencies with things like drop-down arrows that say, okay, this has to be done before this task can start, and so on. Go back to the thing. So the task duration is represented by its horizontal length. In other words, instead of a number like you have on the Pert chart, on the Gantt chart, it's like if it's 3 weeks, you're 3 weeks over on the calendar scale, or whatever the scale happens to be at the top. That gives you more of an immediate sense, and usually with fancier Gantt charts, you have, here are the personnel assigned, or here's the number of hours we estimate it's going to take, and of course, you often from there start to drift into person hours. And person hours are often misused the same way man months are misused. You think, okay, it's 40 person hours, we'll assign 2 people, we can get it done in, you know, a 20-hour gap. Doesn't always work that way. It's not as compact as PERT. It's harder to see. With PERT, you can abstract down to a level so you get a good sense of what you're telling yourself. So here we have just major efforts within the project and the estimated start dates and completion dates. We've got color coding. This one uses color codes for who's responsible. Yeah, let's throw my glasses around. You can define key milestones and so on. This is perfectly acceptable if you want to do something like this. Again, Google Gantt chart, you will see dozens of variations. As I said, this is from, I'm pretty sure this is from Microsoft Project or something that looks an awful lot like Microsoft Project. Huh?
I think it's Matchware.
Matchware? Okay. So you've got your tasks, very detailed, the duration, start dates, and you can see here, you can get a visual sense of the, oh, Matchware. There you go, mine view 3D. You can get a visual sense of it, but you have to scroll way over to see the full duration of the project. A lot of them will allow you to compress down the calendar scale. So, for your Gantt chart, you need the same data. In other words, what are your tasks, dependency duration. You may use different abstraction for your Gantt chart than for your Pert chart. By that, I mean you may block up the areas differently, particularly for your initial cut, and then do further detail within it as you go along. Unlike Pert charts, actually you'll find Pert charts that actually have a lot more detail in little boxes, like, you know, here are the people assigned, and here's you know, number of programmer hours we expect versus number of days or number of weeks. Again, you can use whatever tools that you agree on as a team. You want to make sure your Pert and Gantt charts are actually describing the same thing. You may have, like I said, you may have different abstractions, but the dates should line up well, particularly ship date. Yes?
So, aside from the project schedule and finding the critical path, what are the other things that these tools are useful for?
Well, they're often useful to say, are we late?
Okay. That's good enough.
In other words, here's our estimate, and one of the signs I look for is an expert witness or as a IT consultant that I'm reviewing a troubled or a failed project. The question is, were the schedules kept up to date? Did anyone actually use them? What I often see is a situation where you have something like this. Something like this that's been created and has never been updated. And when people actually say, well, where are we at? It's like, well, we don't know because we really haven't updated this, and we don't know, what's going on here. Gantt charts are often used to try and estimate person loading. Often with projects, you'll have people that you roll on and off for specific tasks, so the Gantt chart can help you to understand what you're going to need to do there. What you'll find throughout a lot of industry is that these really aren't used in a lot of places, and a lot of the scheduling is seat of the pants. Sometimes this is done because you've got actually a disciplined, agile approach going on. They're doing sprints. And it's like, here's what we're at now. This is where we want to be in a week, 2 weeks, 4 weeks, whatever the sprint duration is. And that's what they're focused on. And basically you have a project cycle within a 2 to 4 week period. Other places will say we're doing sprints and they're simply sort of running as fast as they can, so to speak. And they keep looking at stuff and trying to figure out if they can push it out the door. Just had a conversation with my son-in-law yesterday at dinner, who works for a company that's remained nameless here in the area, which is easy because I actually don't remember the name of the company. He works in QA, and he was expressing some of his frustrations because for a particular product he's working on, the product manager said basically, in effect, we really don't want you doing rigorous QA. We just want you to test the happy case. In other words, if the user is doing what the user is expected and supposed to do, does it work? And we don't care if the user does something that the user is not supposed to be doing, like literally entering letters into a numeric field. Don't test for that. Don't file a bug for that. My son is ripping his hair out. So there are a lot of organizations that you will find are pretty sloppy on their level of quality as far as schedules. It's just like, let's get something out the door. And this will tie into discussions we will continue to have about technical debt. So there's a podcast, there's a long podcast on project management. I would recommend you watch this, and you can count your time watching this as billable hours, because this is so long. But only for this podcast, only for this week. So if you watch this podcast on project management for this week, be sure to watch it.
Well, so we can count for both
Yes.
the podcast and the book.
Yeah, you basically count both for the podcast, and it's like 2 hours long. So it's 2 billable hours you get out of just watching it. Yes.
If you've already watched it.
Count it as 2 billable hours for this week. There you go. For those of you, I'm not going to penalize those of you who actually went ahead and watched the 2-hour podcast. Anyway, this is Chuck talking, and slide 16. He talks about, let me scale this down. This is something that may be useful to do before preparing your PERT and Gantt charts. He has a task box, which is simply a spreadsheet here where you define your task, your estimated duration, dependencies and other tasks, and milestones you have as a result. If you do this, you will find that your PERT chart and your Gantt chart fall out of this very quickly. So if you watch the podcast, or even just look at the slides of the podcast, and there's his example of the PERT chart and a Gantt chart based on it. So that's something you may want to do as teams, is to get together or assign someone to do this task duration box. And if you spend the time in this format, then whatever tools you select for your PERT and your Gantt chart, you'll find that putting them together goes pretty quick. So that's a tip there. Got some online resources. Yeah, whatever. Okay, so like I said, the task table, which I just showed you, may be useful. That won't be reviewed. You don't have to produce that as a deliverable, but it may be very useful internally. Want a PERT chart that should visually, let me say this again, visually, by color, by some means, highlighting, whatever you want, visually identify the critical path of the PERT chart. The Gantt chart, I'd like you to somehow tie it to either groups within the team or individual team members as far as the various tasks that you identify. Be sure that what you produce can be shared next week, because we'll do exactly the same thing we did with the requirements. We'll have each of you come up, someone from each team come up and talk, show your PERT chart and your Gantt chart, and talk about what painful thing you learned in the process. Those are due by midnight Saturday, and you'll present them in class next week. And with that, let's take a break till, yes?
So I know we have a couple other deliverables, like the architecture design document. Should those be in the Gantt and PERT charts? I mean, should we start the Gantt and PERT charts? And
You can certainly put your other deliverables in the Gantt PERT charts. You don't have to, but if you want to, you can put them in there.
because you can't really start anything until that stuff is done. Like,
Oh, you mean because you can't start coding until that's done?
Right.
Yeah. Yeah, you could very easily put that as a start. So yeah, you need to have architecture design done by the state. Though for a lot of you, you're already doing exploration of technology, you're figuring out how to do stuff, you're doing selection of tools. So there are tasks like that that can, and in some cases probably should be done before you start coding. Or you may be doing prototype coding at this point before you finished your architecture design, maybe doing exploring as per armor to figure out what kind of architecture design will work. So let's take a bathroom break until 10 after, maybe 12 after. And then we'll, actually wait, before